In this video, we're going to look at solving linear inequalities. When we solve linear inequalities, we work the problem, for the most part, like we work solving linear equations. The most obvious difference, of course, is that we're using an inequality symbol rather than an equal sign. And there is one rule that's a little different that you have to consider when you're dealing with an inequality that you do not have to worry about when you're solving an equation. That rule is if you divide or multiply both sides of the inequality by a negative number, you must flip the inequality symbol. And the reason behind that is doing that particular operation will change the order of the two sides of the inequality because it changes the sign on the two sides of the inequality. Let me give you a little example just with some numbers rather than using variables. If we had the inequality 6 is greater than 2, we'll say. If I wanted to multiply both sides of that equation by a negative number, and let's just say for the sake of this problem that I'm going to multiply by negative 3. Okay, so that's going to be negative 3 times the 6th, and then negative 3 times 2. Well, right off the bat, even before we actually do the multiplication, I have already changed this inequality symbol, okay, that should be here in the middle. I'm going to draw a box where I normally would put that. All right, now if we look at what we get when we do that multiplication, you'll see why that changes. Negative 3 times negative 6 is negative 18, and negative 3 times 2 is negative 6, okay? So now the order has changed. Negative 18 is actually a smaller number than negative 6, and so we would need to have a less than instead of the greater than, okay? When you do this with x's, it's not as obvious that your signs have changed because you have variables in there and you don't actually know what numbers the variables represent. So you have to just rely on the fact that you know that multiplying or dividing both sides of an inequality does change the order of the sides, and so you just automatically have to flip that inequality symbol. And that's true for linear inequalities and any other type of inequality that you might encounter. Excuse me. All right, let's take a second and let's just work through a short example of solving a linear inequality. And what we'll do when we get to the answer, the solution, we'll write it in each one of those three notation forms that I showed you in class. So this example, let's do 3 times x minus 1 is equal to 2x plus 9, okay? And not equal to, sorry. I'm going too far back to equations here. Let's do maybe greater than or equal to, okay? So the first thing we want to do, just like we would with an equation, is you want to simplify each side. So I need to do the distributive property here. Okay, I don't have any like terms to combine, so the next step is to try to move the x's to one side and the constants to the other. So if I subtract that 2x from both sides, I get an x over here, and if I add 3 to both sides, that's going to give me a 12 on this side. Okay, now in this particular problem, I don't have a negative that I need to multiply or divide both sides by, so I don't have to worry about flipping the symbol like I did or like I was talking about a minute ago with that rule. You do want to, on each one of the problems, you want to kind of ask yourself if you need to do that, and that way it keeps that particular rule in your mind as you're working through the problems. So inequality notation-wise, we're done, okay? That is our answer. X needs to be greater than or equal to 12. So in set builder notation, that would simply be x such that x is greater than or equal to 12, very simply, okay? That's set builder. The graph, we would draw a number line. 12 is the number that's in my solution set, so 12 is the number I need to graph. I have greater than or equal to as an operation symbol, so the or equal to part tells me that 12 is included in the set, so I'll use a bracket, square bracket. on the 12, and then I need to look to see which side of the 12 I'm going to graph. If x is supposed to be greater than or equal to 12, then that'll be all the numbers that are to the right of 12. So I'll come in here, and I will put a bracket at 12, okay, and then we shade, whoops, to the right. I got a little carried away with that, didn't I? A little too far past my bracket. Sorry about that. Okay, so that's the graph. Okay, it is showing me that x can be equal to 12 or bigger than 12, which is what greater than or equal to means. And then our last notation is the interval notation that we talked about. And that is really easy to get when you've already got the graph in front of you. If you don't have the graph, then you can learn to set it up correctly. In interval notation, you need the endpoints of the interval. And since x is greater than or equal to 12, the smallest number that can be a member of that set is 12. The largest number is kind of open-ended because this graph goes off to positive infinity to the right, so infinity is on the other end. Since we had the or equal to, on the 12 I put a bracket, just like I did for the graph. Those symbols will match. And then for the infinity, we always use a parenthesis. So you get a parenthesis there. So that gives you set builder, the graph, and interval notation, okay? And depending on which homework problem you're working, you may be asked for all three, or it may just ask you for one of those notations. Just watch your instructions. Same thing with WebAssign. Watch the instructions there too. One quick little one where we have a negative value that we need to multiply or divide both sides by. We'll just do a real quick, simple, linear example here. Maybe negative 2x plus 6 is less than 3. Okay, so I'll go ahead and solve this just like I did the other one. I don't have any simplifying to do, so I can go ahead and isolate x. We need to subtract the 6 from both sides. And then divide both sides by the negative 2. Now, when you divide by negative, the same thing happens as when you multiply by negative. You change the order of the sides. And so just by dividing by that negative 2, I need to flip the inequality symbol. Now, one thing I want you to notice is the inequality does not consume that negative. You're still dividing by the negative 2. So that would give me a negative over a negative. That's my answer. That's your inequality notation. And if we want to do the other notations right quick, set builder, x such that x is greater than 3/2. The graph, the number is 3/2. I mark that on there. It's less than, so it'll just be a parenthesis, and I want greater than again. So parenthesis at 3/2, and then shade in to the right, where all the numbers are larger. For interval notation, we need the two endpoints. 3/2 is where we start, even though we don't actually include 3/2. The parenthesis shows us that. We do start at 3/2, and we go on to positive infinity. Infinity always gets a parenthesis, so we end our interval notation with a parenthesis there around the infinity. Okay, so that gives you a couple to look at for linear inequalities. Work a few in the homework to get a little practice on that, and we will talk about it on Wednesday. Or Thursday. Depending on which class is watching this video, sorry. Whichever class you're in. We'll talk about this in the next class period.